So we are going to graph this function, f of x equals 2x plus 1 over x minus 3. And we're going to walk through each step. Depending on how complicated your function is, there could be between 6 or more steps. But we're going to cover the basics and see if we need to add any more information or add any more steps to figure out what this graph looks like. So the first thing that I like to start out with is I like to start out with vertical asymptotes. They are really easy to identify, and you can just put those right on your graph instantly. So vertical asymptotes come from your denominator. So they come from this x minus 3. And vertical asymptotes are where your function is undefined. And so the only situation that's going to happen is if your denominator is equal to 0. And in this case, x would equal 3. So I'm going to go over to our graph, and I'm going to put a nice dotted vertical line for our vertical asymptote on x equals 3. And then the question becomes behavior around that vertical asymptote. And so this is a factor raised to the first power. So we could rewrite that as x minus 3 to the first power. It's still the same thing. And what that means is that around the vertical asymptote, your function is going to be going in different directions. So I am just going to put arrows going in opposite directions. Now, I don't know if this is actually the situation. It could be vice versa. So it could be going up over here rather than down, and it could be going down on the left rather than up. But I'm just showing to myself that they're going to be going in different directions rather than the same direction. All right, so there's vertical asymptotes. Now, the other thing that's really easy, usually, to identify is horizontal asymptotes, so long as that there is no slant asymptote. And in this case, we have the degree in the numerator being the same as the degree in the denominator. So it's only a degree 1. So you just take the leading coefficients. So in this case, we have a 2, and we have a secret 1 out front. So our horizontal asymptote is y equals 2 over 1, which is just 2. So I'm going to go over to my graph and put down a horizontal asymptote of y equals 2. And remember that your function can cross that horizontal asymptote as many times as it wants. In the middle, not out to the infinities, negative infinity and positive infinity, because horizontal asymptote is just end behavior. For vertical asymptotes, your function cannot cross that, because that's where your function is undefined. So there are our vertical asymptotes, our horizontal asymptotes. Now let's look for x-intercepts. So x-intercepts, that happens when y is equal to 0. And I will write out the entire fraction first, and probably in the next couple examples I will not, because if you notice, that denominator plays no role in this. All we need is your numerator equal to 0. 0 divided by anything is 0. You could also think about multiplying that x minus 3 over, and then 0 times x minus 3 is 0. So all that matters is that the numerator is equal to 0. So x is equal to negative 1/2. So I am going to, at negative 1/2, make a nice marking saying that that's my x-intercept. And remember that it comes from a multiplicity of 1, which means that you are going to be crossing through it. So I'm going to write a c. It's not going to be bouncing off of it. So remember that from polynomials, that if it was an even degree, then your function would bounce off of that x-intercept and go back up or go back down, depending on which direction it was coming from. But in this case, it's just going to cross right through it. So there's x-intercepts. Notice how I am writing everything down on my graph as soon as I find it. So I'm not leaving anything to the last minute. I'm not trying to put all the puzzle pieces together all at once. I am just putting them all on at this as I find them to make it a lot easier for myself. Now for the y-intercept. Y-intercept happens when x is 0. So when x is 0, we are going to have y equals 2 times 0 plus 1 all over 0 minus 3. So I'm just plugging in 0 for all of the x's. When I do this, we have a 1 in the numerator and a negative 3 in the denominator. So y equals negative 1/3 for the y-intercept. So again, it's just a sketch. It doesn't have to be perfect, but I'm going to make some marking around negative 1/3 so I know that that's my y-intercept. All right, and that seems to be about all of the information I'm going to need. Now, I could make a table of values over here or wherever you'd like, and start plugging in values to help get some more points on this graph. But I can figure this out just by reasoning with all the information on my graph. So I know at the vertical asymptote, my function is going in different directions. I know at the horizontal asymptote, I need to be following that out. I know that it can't cross the x-axis anywhere except at the x-intercept I've already identified. So the only place it can cross the x-axis is right there at negative 1/2. I think it's easier to start on the edges rather than starting in the middle. So I am going to come from this direction, cross through my x-intercept, cross through my y-intercept, and then ask myself, do I need to bring the function up or do I need to send it down for that vertical asymptote? And I know it has to go down for the vertical asymptote because it can't cross the x-axis again. I have no x-intercept to allow it to cross and go up. I was just making those arrows in the blue to show myself that it's going in the opposite direction. So now I know that it's going down right here. So I know it has to be going, coming from the positive direction on that side, on the right side of the vertical asymptote. And I know it has to follow my horizontal asymptote, and I know it can't cross the x-axis. So then it's just a matter of connecting those two pieces. And I get this for my function.